For this video, we're going to be discussing the properties of quadrilaterals. So a quadrilateral is any four-sided polygon, right? And there are a bunch of different types of quadrilaterals, and they are categorized by their different properties. And we're going to spend some time in this video just going through the properties of each of the individual types of polygon or of quadrilaterals. So in order for a shape to be a quadrilateral, just has to have four sides. That's all there is to it. The next most specific type of quadrilateral is a parallelogram. All right, and in a parallelogram, there are some properties that are true about it. In every parallelogram are opposite sides, so sides that are across from each other, they're non-adjacent. They're going to be parallel to each other. Okay, and we denote parallelism by having the same number of arrows facing the same direction written on them. And our opposite sides are also going to be congruent. Okay, so in every parallelogram, opposite sides are both parallel and congruent. Also, our opposite angles are going to be congruent. All right, and consecutive angles, being angles that go together, or angles that are sharing a side that are next to each other, those angles are always going to be supplementary. So like here, the measure of angle A plus the measure of angle B is always going to be equal to 180 degrees. All right, so supplementary or consecutive angles are always supplementary in a parallelogram. And the other thing that's true is that the diagonals bisect each other. So the diagonals are simply lines that connect opposite vertices. So AC is a diagonal, and so is BD. And the property that quadrilaterals have, or not quadrilaterals, that parallelograms have, is that if we called their intersection point E, AE is congruent to CE, and BE is congruent to DE. So our diagonals bisect each other. Now notice our diagonals are not congruent, they just cut each other in half. So those are all the properties that go along with being a parallelogram. Now if we were to get slightly more specific, we can get to a rectangle. Now in a rectangle is also a parallelogram. That should say parallelogram. G in here. Parallelogram, all right? So everything that holds true about a parallelogram also holds true about a rectangle. Opposite sides are both parallel and congruent. And our diagonals are still going to bisect each other. But there's some new things that we have to talk about when we get to rectangles. And those new things are that every angle is a right angle. So every angle measures 90 degrees. That's the defining characteristic of a rectangle, that all of the angles are 90 degrees. And not only do our diagonals bisect each other, but our diagonals are also congruent. So BD is congruent to AC, and all of these four segments formed when they intersect, these four segments are all congruent. If I put the midpoint of our diagonals in here, call that E, then AE, BE, CE, and DE are all also congruent. So those are the properties of a rectangle. Everything that is true about a parallelogram, plus all of the angles are right angles, and all of the diagonals both diagonals are congruent. All right, getting not quite more specific, this one kind of moves over to the side a little, is a rhombus. Now a rhombus is not a rectangle, but a rhombus is also a parallelogram. So once again, all of our parallelogram properties are true again. Okay, opposite sides are parallel and congruent. Opposite angles are congruent. Consecutive angles are supplementary. All right, but the thing that we add in is not, is it just that opposite sides are congruent, it's that all four sides are congruent. All right, that's what makes a rhombus. It's got 1, 2, 3, 4 congruent sides. The other thing is our diagonals not only bisect each other, these lines aren't exactly perfect, but these diagonals also, they bisect each other, so this segment is equal to this segment, and this segment go to this segment. But what's also true is that our diagonals form 90-degree angles. They're right angles, they're perpendicular to each other. So the diagonals are perpendicular to each other, and also our diagonals bisect the angles that they cut off. Meaning, if I draw in DB here, then angle ADB, this angle here, is going to be congruent to angle CDB, this angle here. So the diagonals cut the angles perfectly in half. So these are our properties of rhombi. Rhombi being the plural of rhombus. Okay, all the properties of parallelogram, all four sides are congruent, diagonals are perpendicular to each other, and the diagonals bisect the angles. And if we take all of the properties of a rhombus and all of the properties of a rectangle, and we put them together, this shouldn't say square. Of course, a square has the properties of a square. If we take all the properties of rectangles and rhombi, we put them all together, then we have ourselves a square. So in a square, all four sides are congruent. Opposite sides are parallel. All of our angles are 90 degrees. If we draw in the diagonals are congruent. They bisect each other. So these segments are all congruent. All of the angles where the diagonals intersect, those are all 90-degree angles. The diagonals cut these angles in half. So it's all of those properties put together. There's a lot going on in a square. So you're going to be responsible for knowing that all of those properties apply to a square. So now we're going to kind of move away. All of what we've been talking about so far have been the different types of parallelograms. So we've got a general parallelogram, a rectangle, a rhombus, a square. Those are all parallelograms. The next shapes we're going to talk about are not parallelograms, they're trapezoids. Okay? And whereas in a parallelogram we had two sets of parallel sides, in a trapezoid we only have one set of parallel sides. And that set of parallel sides is known as the bases. Okay? So in a trapezoid, the bases are the parallel sides. And the non-parallel sides, the other two, they're what are called the legs. Okay, so we've got bases are parallel, legs are not. So that's the main property of a parallelogram, is that it has one set of parallel sides. And then we have this thing called the median. So if I construct the midpoints, let's call them M and N of my legs, and I draw a line connecting those two midpoints, that's what we call the median. All right, and it has some properties. One of the properties is that it's parallel to both of the bases. And the other property is that its length is half the sum of the lengths of the bases. So if I took the length of DC and I added it to the length of AB, and I took that whole thing and I divided it by 2, that would give me the length of NM. So the median connects the midpoints, it's parallel to the bases, and its length is half the sum of the lengths of the bases. Okay, and these are the properties of a trapezoid. Then we have what's called an isosceles trapezoid. It's got all the properties of any trapezoid. Okay, so the bases are parallel. I'm not going to draw in the median. But it also has the property that its legs are congruent. And because its legs are congruent, so are its base angles. And that means that angle B is congruent to angle C, and angle D is congruent to angle A. So the angles at each base are congruent to each other. And also, if we draw on the diagonals are congruent to each other. So AC is going to be congruent. Sorry, not A. Yeah, AC is going to be congruent to DB. And those are our trapezoids. Okay, a general trapezoid, one set of parallel sides. An isosceles trapezoid, one set of parallel sides, and the legs are congruent. And our final type of quadrilateral that's kind of outside of the other ones is what's known as a kite. And kites are weird. Okay, a kite does not have to have any parallel sides at all. But what it does have is it has 2 sets of congruent consecutive sides. So that means, like in this shape, BC and CD are congruent, and BA and DA are congruent. And those are our 2 sets of congruent consecutive sides. Consecutive because they share a vertex. Okay? Another thing that's true about them is that they have 1 set of congruent opposite angles, meaning the angle at B is congruent to the angle at D. All right? Because it's always going to be the angles between our non-congruent sides that are going to be congruent to each other. And then if we draw in our diagonals, I forgot to write this in here, but similar to what we have in a kite, our diagonals are going to be perpendicular to each other. Right? Diagonals are always going to form right angles in a kite. In fact, sometimes a kite can be a rhombus or a square. A rhombus is actually a special type of kite. A rhombus is what happens when you take a kite and you cross it with a parallelogram. And that kind of brings us to our final thing, and it's this drawing. It's kind of a flow chart. And it basically says that if we take a quadrilateral, and some places do this. I actually don't like this line here. Okay, if we take a quadrilateral, I'm going to say, I don't like this line being here. I'm going to get rid of it. Okay, a quadrilateral can split based on the number of parallel sides. If it doesn't have any parallel sides or any special properties, it's just a quadrilateral. If it has 1 set of parallel sides, it's a trapezoid. And if we lived in Great Britain, they call it a trapezium. We don't need that. We don't live there. It's a trapezoid. Okay? And on the other side, if we have 2 sets of parallel sides, it's a parallelogram. And if we have no sets of parallel sides, but we do have these congruent consecutive sides, then we've got a kite. All right? So every parallelogram is a quadrilateral. Every trapezoid is a quadrilateral. Every kite's a quadrilateral. All right? And then from parallelograms, it breaks down a little bit more. If I've got my 4 right angles, I've got a rectangle. And if I've got 4 congruent sides, then I have a rhombus. But notice that a rhombus is also a kite. And that's because, well, in a kite, I've got 2 sets of consecutive congruent sides. In a rhombus, I also have 2 sets of consecutive congruent sides because all the sides are congruent. So a rhombus is also a kite. And then if I take a rhombus and a rectangle and I take all of their properties and put them together, I get a square. All right? So if I notice that, a square, we can say is also a rhombus, it's also a rectangle, it's also a parallelogram, and it is actually also a kite, and it's also a quadrilateral. Now I'm deleting these lines because there's some debate as to whether we should say a parallelogram is a type of trapezoid. Some people say there is, some people say it's not. Some people say a trapezoid has exactly one set of parallel sides. Some people say a trapezoid has at least one set of parallel sides. It's something in math that's debated. We're going to side with it has exactly one set of parallel sides. So if I've got a trapezoid, the only thing that's underneath that is going to be an isosceles trapezoid. So if you were to find out that a shape was like, say, a rectangle, that means it's also a parallelogram and it's also a quadrilateral. If it's a square, then it's also a rectangle, a rhombus, a parallelogram, a kite, and a quadrilateral. So you can see that this flowchart kind of shows exactly how the different quadrilaterals are related to each other. And that's all we've got for the properties of quadrilaterals.